Let fx equals x cubed minus x minus 2 upon x minus 1 times x squared plus 1. Express fx in this form, which is partial fraction form, where a, b, c, d are constants. Okay, so while doing partial fraction, the first thing we need to see is that the degree of numerator and the degree of denominator, they're the same. X cube is the highest power in numerator and so is it in denominator. That means we will first have to do long division of this and fix this. This is an improper fraction right now. We'll change it into a mixed fraction. Okay, so expand the denominator, we'll get x cubed plus x minus x squared minus 1. So x cubed minus x squared plus x minus 1. Let's start the long division process. In fact, here I should also write 0x squared in between. So a plus 0x squared minus x minus 2. Let's start long division. So we'll just have to write 1 here and then x cubed minus x squared plus x minus 1. Change the signs, minus, plus, minus, plus. This gets eliminated. We get an x squared minus 2x and minus 1. So the mixed fraction becomes 1 whole x squared minus 2x minus 1 divided by this, and I'm writing this in a product form again, which is x minus 1, x squared plus 1 in factorized form. And then we can add a plus sign here. Okay, so we get 1 whole plus the other fraction x squared minus 2x minus 1 upon x minus 1 over x squared plus 1. Now the degree of the numerator is 2 and the degree of denominator is 3. So now we're ready to do partial fractions of this. So x squared minus 2x minus 1 upon x minus 1 and x squared plus 1 can be written as a upon x minus 1 plus, in fact, they've written b, so we'll write b as well. B upon x minus 1 plus, since this is quadratic, so we'll write cx plus d upon x squared plus 1. Okay. Now we're going to make the denominator same on both sides. X squared minus 2x minus 1 upon x minus 1, x squared plus 1 is equals to b. This gets multiplied with x squared plus 1, both in the denominator and numerator, and cx plus d gets multiplied with x minus 1, both in the numerator and denominator. So now both the denominators become the same, which can cancel out, and we get x squared minus 2x minus 1 equals b bracket x squared plus 1 plus cx plus d in a bracket times x minus 1. Okay, now we can first substitute x is equals to 1 to make this 0 and get the value of b. So we'll have 1 minus 2 minus 1 on one side times b bracket 1 plus 1, 2. So we have negative 1 for b. Okay. Okay. Now we need to find the value of c and d. So we can make x 0 and also use b is equals to negative 1. So this becomes just negative 1 equals minus 1 times 1 plus c becomes 0 and we get d times negative 1. So we get d equals 0. Okay, now we need to find the value of c. So for that, we can use another simple value of x. We've already taken x equals to 0, x equals to 1. Now I'm going to take x equals to negative 1. And we already know b is negative 1 and d is 0. and we can use these three to find the value of c. Okay, so this will become 1, then a plus 2, then a minus 1 equals negative 1, and inside we'll get a 1 plus 1, 2, plus we get a cx, so that will be negative c, plus d is a plus 0, times negative 1, which is negative 2. So now we're getting 2 here is equals to negative 2 plus 2c. So 4 is equals to 2c and c is equals to 2. So this becomes, there's a 1 first, 1 is a, plus this will be rewritten as this. B came out to be negative 1, so I'm going to write negative 1 over x minus 1 plus 2x plus 0, so just 2x upon x squared plus 1. We have the results of the partial fraction. Okay, in part 2, we will now be integrating it within the limits 2 to 3. Let's get started. Okay. So integrate from 2 to 3, 1 minus 1 upon x minus 1 plus 2x upon x square plus 1. Okay, integration of 1 dx here. Integration of 1 is x minus, for this one, we're going to use the case 1 over fx. Integration of this is ln fx as long as fx is linear upon f prime x. So this will be minus ln x minus 1 upon the derivative of x minus 1, which is just 1. Now plus, okay, for this one, we're going to use the rule integration of fx. So if fx is nonlinear, you must have its derivative in the numerator, and this is equals to ln fx as well. So we have the derivative of x squared plus 1, which is 2x in the numerator. So this will be equals to ln x squared plus 1. And the limits would be 3, 1. We can just ignore this divided by 1. Okay. Now we substitute the limits. So 3 first and then 1. So 3 minus ln 2 plus ln 10. And then 1 minus, sorry, this was 2. So 2 minus ln 1 plus ln 4 plus 1, 5. Okay, so we get 3 minus ln 2 plus ln 10 minus 2 plus, in fact, this is just 0, so we can ignore it. Then minus ln 5. Okay, we need to show that this is equals to 1. So we get a 1 here. Then we have minus ln 2 plus ln 10 and minus ln 5. Now we're going to use log rule here, and we know we can take ln common, and the plus values go in the numerator and the minus values go in the denominator. So we get 1 plus ln 1, which is also 0. So the answer comes out to be 0, 1, and that is what we were supposed to show, that the answer of integration equals 1.